Okay, out here in the real world, most thermodynamic processes are clearly irreversible. Your text, I think, talks about the example of sliding a book along a tabletop. You have this thermal energy dissipated in the process. Now we say it's dissipated. What do we mean? We mean that we can't really get it back. We can't take back that thermal energy and make it move the book back along the tabletop, along the path that it just came along. Okay, we'd have to do something else to reverse that. Well, we couldn't reverse the process. We'd have to do something else to make the book move the other direction. Okay, so that process is irreversible. The processes that we used in the bottle engine are irreversible. We can't take the work that we did by raising the water and cause that work all to go back into the system and bring the temperature of the system back to what it originally was. Okay, that's not an irreversible process. Okay, processes aren't ever really quite reversible, but a reversible process, or a quasi-equilibrium process as we're going to call it, a quasi-reversible process, a process that for all practical purposes is so close to reversible that it doesn't matter, that it's not quite reversible. That's a process that happens near equilibrium. Okay? If we're near equilibrium, and that means that we have small temperature gradients and small pressure differences. Okay? Near equilibrium, temperature gradients and pressure differences are going to be small. If we have a large temperature gradient, we're not going to have an equilibrium situation. We're going to have a lot of flow from one direction, in one direction or in the other. But if we use small temperature gradients and small pressure differences, there isn't much energy flow, so we stay near an equilibrium state, and then by simply changing the state back in the other direction, we can get the process to move back in that direction. Okay, so we have these quasi-equilibrium situations where we have small temperature gradients, small pressure differences, and small changes in the system can be reversed and cause the process to reverse. Okay, so then we get this. The natural direction of things, though, is from order to disorder. We do work, and we usually dissipate thermal energy. Dissipated thermal energy is disordered. If we allow a gas to expand out into the air, the gas is very organized. It was all there in a container. Now we let it expand out into the air. It's all over the place. It's disordered. So we have this natural direction of processes from order to disorder.